All right, so I'm looking at the January 2025 Regents for Algebra 1. There's a lot of information here. This will all be read to you on the day of the exam. There are some things that are, I think, probably pretty obvious, like your name and the school you go to. But then there are other things that are kind of like in the weeds here, like scrap paper is not permitted for any part of the exam, but you can use the blank spaces in the booklet as scrap paper. Right? So they have that the sheet of scrap graph at the end. They say it's helpful but not required. They don't allow scoring of anything that's written on that scrap graph. Right, so that's kind of like it's what you would use if you wanted to. Let's say, for example, find the slope between 2 points for a multiple choice question. You could just kind of plot those points on that grid and do the rise over run and see what it is kind of manually. But they wouldn't be looking at that to give you credit for anything, right? And then your answer sheet, when all is said and done, there's a little declaration that says that you didn't cheat, so you're gonna need to sign that to indicate that you didn't cheat on the exam, and that you didn't have access to any materials that you shouldn't. All right. The proctor will let you know when you can begin, and once they give you the go-ahead, you can get right to it. You have 24 questions in part one, right? So I kind of glossed over that a little bit. All of the early part here, separate answer sheet for part one has been provided. Follow the instructions, all that good stuff. And then you get into the parts 2, 3, and 4. Those are the short answer components. And for those, you're expected to show all your work directly in the booklet. So there isn't an answer page for that. You just get right to it. Right? So you just write your answers in the answer booklet. You make sure that you answer the question fully and also support your answer with the appropriate work. All right, so there we go. So that's a little bit on that. The graphs can be drawn in pencil, but everything else has to be done in pen. Right. So what a lot of people will do is I'm not saying that this is the best way to go, but they'll write their work in pencil, and then when they're confident that they have on paper what they want to have on paper, they'll trace over it in pen. The problem with that is if you miss something, then we run into a little bit of an issue. All right, so yeah, that's something you'll be reminded of, but I figured I'd mention it here. All right, so you get on to the exam. The first question, is asking when factored. You have an expression here. What is it equivalent to? There's a couple ways to handle it. One would be to actually factor it using factoring techniques that you've learned in class. The other would be to distribute out the 4 choices. Now I see that there is a common factor here. All right, so I see I have an x here and an x here. I have a common factor of x, so I can pull that out. All right, I'm just going to bring that down here. So it'd be x times, then if I divide each term by x squared minus 36. All right, so that's automatically going to wipe out these 2 choices. Right, and that's because there should be a factor of x out in front of your final answer, and those 2 choices don't have a factor of x out in front. Right. Then we look at this. This is a difference of perfect squares. All right, so I can factor that. 2 binomials. I'm going to bring that x in front. All right, we take the square root of the first term. That goes here and here. So it's going to be x and x. No help there. Then my second term, 36. Take the square root of that. 6 and 6. And for a difference of perfect squares, we alternate the signs, 1 positive, 1 negative. Right, but once you recognize that it's going to be 6, you can You can dismiss choice 4 and go right for choice 3. All right. Another possible approach, and this is like in case of emergency, you could pick a value for x and put it into all 4 choices and see which one is equivalent to what you started with. So that's what you would do if you're like in a jam and you're like, I don't really know how to do this. So if I did x to the third minus, 36x, all right? So I can put that in, and I actually can do it with numerical values if I wanted to put in like a different variable like a. But what I would be looking for here, and I'll just go right to the right answer here, is the choice that produces the same graph. All right, so if you tried one of the other choices, you'd see that it would give you a different graph. I'll just do one other choice here. I can duplicate this and get rid of the x. All right, so let's say I thought this was the right answer. Compare it, it's not the same graph, so it wouldn't be the right answer. All right, on a similar thought or using similar approach, I could use my calculator to figure out choice 2. All right, I'll show you the algebraic way, but then I'll also show you the calculator approach, because really you're just looking for the equation that would have those 2 points on it, right? So using duplicate, it's easy enough to type in a bunch of choices, right? But you could also type them in manually. But let's say I wanted to do this by hand. I would find the slope, which is my change in y over change in x. All right, so I'll take my 8 minus negative 2 and divide it by negative 1 minus 4. So that's going to be 10 over negative 5, which is negative 2. All right, so I'm going to wipe out these 2 choices because the slope is the value in front of the x variable. And we have 2 choices in which that value in front of the x variable is negative 2, but at least I was able to knock it down from 4 choices to 2 choices. All right, so then I would use, again, doing it manually, y equals mx plus b. I'll choose one of the 2 points. Doesn't matter which one, as long as you grab both coordinates from that point. I'm going to put the 8 in here and the negative 1 in here. So we're looking at 8 equals, I have that slope, we just figured it out, negative 2 times negative 1 plus b. So 8 equals 2 plus b, subtract off the 2, and I get 6 equal to b. All right, so my answer here, again, in the form of y equals mx plus b, y equals negative 2x plus 6. So it's going to be choice 1. And like I said, you could figure it out based off of plotting the points. All right, you want to see it, so I'm going to pinch zoom. 4, parentheses, 4, negative 2. And then y equals, we'll start with the first choice. It turned out that was the right answer, but let's say I didn't know that. I would probably start off with the first choice and just see if it passes through the 2 points. Like if I thought it was negative 2x plus 10, it misses the points. If I thought it was negative 0.5 x plus 7.5, it gets one of the points but not the other point. Right? It's got to get both. All right. The mistake that they made here in coming up with these choices is that they did change in x. So they did delta x over delta y, change in x over change in y, instead of the correct way of doing it, which is change in y over change in x. So that's something to be careful about. It's change in y over change in x. Trying to get rid of all this extra stuff here so it doesn't confuse down the line. Geometric sequence. In a geometric sequence, we're looking for the common ratio. So the number that you multiply one number by in order to get the next number in the sequence, right? So there's two ways to do that. One would be to just say, well, I think if I take -1/2 and multiply it by whatever number, I'll get a 2. And then the 2 multiplied by that same number should get me an 8. Now maybe 1/2 times, maybe you can't figure that out quickly, but you should be able to figure out how you're getting from a 2 to an 8. That's times 4, all right? And just make sure that that happens every step of the way. That's true. And if I take 1/2 and multiply it by 4, I can do that in here also. All right, so 1/2 multiplied by 4, that does give me a 2. All right, so that's my common ratio. My common ratio is 4. All right, the other way to do it, it's not much more complicated, but if you take any two values, any two consecutive values, and divide the second value by the first value, all right, so my common ratio R would be 8 divided by 2 would be equal to 4. And you might ask, okay, well, what if I chose a different pairing? You're going to get 4 anyway if it's a geometric sequence, right? You just got to be careful. If I did 2 divided by 1/2, a lot of people think, well, I'll just do that in my head. 2 divided by 1/2 is equal to 1, but it isn't. So 2 divided by 1/2 is equal to 4, right? So you're thinking, because 1/2 is 0.5, how many of those 0.5s would I need to get to a 2? I'd need 4 of them, 0.5, 1, 1.5, and then finally 2. The constant term in a polynomial is the term that doesn't have a variable attached to it. You just got to be careful because we're looking for the sign also. Now in this case, they only gave positive possible outcomes, or choices I should say. So it's not really an issue, but it could be. All right. I don't remember off the top of my head, so I'll just address it here. This is, again, constant because there's no variable attached to it. Now, when I say no variable attached to it, I mean through multiplication. It's just a standalone 5. It's not 5x, right? So everything else would not be a constant term. Then the degree of the polynomial is the highest power in the polynomial. All right. So the highest power in the polynomial is the degree. And then whatever the coefficient is attached to that term, the one with the highest power, is your leading coefficient. And it does not necessarily have to be the first coefficient. All right, I'll write an example in a second. So let's say, for example, I had 2 minus x squared plus 1/3 x cubed. All right, this is my constant. Constant would be a positive 2. If there were a negative sign in front of it, it would be a negative 2. All right, this is my degree. And this is my leading coefficient. And you see how it's the last term, not the first term. All right. Doesn't necessarily have to be the last term either. It could be anywhere within the polynomial. It could be a middle term. All right. Moving on, number 5. Landscaping company charges a set fee for spring cleanup plus an hourly labor rate. Total cost is modeled by the function C of x is equal to 55x plus 80. In this function, what does the 55 represent? Right? So that's a slope. It's a measure of the slope. And so what we need to determine is what the slope represents in the context of the problem. So I'll write it off on the side here. We have 55. C of x is equal to 55x plus 80. Right? That 80 is a fixed value. That's not going to change. right? The the X would represent generally the number of hours that, when we use a cost model, it would represent the number of hours for which you're doing work or whatever it happens to be, right? So that's the one thing that would vary. If you're dealing with an hourly labor rate, which is what that 55 would be, then the unit of measure for X would have to be hours. So these two things need to be consistent, right? Now, without even looking at the choices, that we could evaluate our function. We can put in an X value, for example. If I said X is equal to 0, then that would mean that if I spent no time doing work, it would still cost me $80, right? So it's going to cost 80 plus 55, so what is that, $135 for 1 hour of work. It'll cost me another 55 on top of that, so it'd be like 190, I think, for 2 hours of work, and so on, all depending on how many hours you're working. So that's the input-output kind of thing going on there. So I can put it into my calculator. I know this is beyond what they're asking, but I just thought it would be a good idea to show you how you can evaluate in your Desmos calculator. So let's say I wanted to know how much it would cost if no work, no amount of time, no hours were spent doing the work. It would be $80. That would be my cost. And let's say I wanted to do 5 hours worth of work, it would be 355. So just by using the notation, I can manipulate my whatever's in the function numerically. I can manipulate that, and it'll produce whatever answer I'm looking for, right? So the 55 here is your hourly labor rate for a cleanup. So that's choice 2. It would not have been number 3, right? Well, it wouldn't be any of the others, obviously, but specifically number 3, because profit is a particular definition. Profit is equal to revenue minus cost. So if they don't tell me the revenue, then there's no way I can figure out profit, right? And all they talked about here was cost, so that would be out immediately. Number 6, which expression is equivalent? Looks like we got the difference between two polynomials. I can distribute my negative here. So I'll write it down here. 5x squared minus 2x plus 4. I'll drop the parentheses there because we're not operating on that. We're not multiplying it by anything or anything like that. Minus 3x squared minus 3x plus 1. Then I can combine my like terms, making sure to account for the signs along the way. So 5x squared minus 3x squared is 2x squared. Negative 2x minus 3x is negative 5x. And 4 plus 1 is 5. All right, so I combine those terms. That got me the 2x, the negative 5x, and then the 5 itself. All right, so I look for the choice. It looks like it's choice 2. So we're good there. For a system of inequalities, when you're looking for a solution in the system, you're looking for the part that's double shaded, all right? So when I look at my graph here, I can just kind of play it out and see which point falls in the double shaded area, right? 1, 1 plots here. That's on the dotted line, which means it's not included in the solution set for this line. So it would be included in the other one, but it's not included in the dotted line, all right? So that's out. 2, negative 2, same deal, falls on the dotted line, so that's out. 1, 8 1, 2, 3, 4, 5, 6, 7, 8. That goes up here. It's not in the double shaded area, so that's out. 1, 2, 3, 4, 1, 2. That is squarely in the double shaded area. So we're looking at choice 4 here for number 7. Number 8, arithmetic sequence. First term is 25 and the third term is 15. What is the 10th term? Right? There's a couple of ways to do it, just like I guess I feel like I've been saying that about a lot of things. One way would be to identify the common ratio, a common difference, sorry, it's arithmetic. For a geometric, it would be common ratio. So my first term is 25, so that's my a sub 1. Second term, don't know what that is. Third term is 15, and they're saying follow that trend till you get to the 10th term. All right, so one way to do it would be to write the rule. The other way to do it would be just to kind of count it out. Either way, you need to know what it's going to take. So I'll say ... what it's going to take to get from here to here and then here to here. And it's got to be by adding or subtracting the same number. That's how arithmetic sequence works. All right. So I'm going to take 2 steps to get from 25 to 15. So I can just kind of guess and check and say, okay, well, I suppose if I subtract a 5 twice, that'll get me to a 15. So my second number here would be 20, 15, 10, 5, touchdown. And just keep going until you get to the 10th term. All right? So if I wanted to, I could actually do it real quick. We're 5 terms in, so then 0, -5, -10, -15, -20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that covers it. So it would be -20. So you can do it that way. If the numbers aren't quite as nice, one thing that you could do is take the difference and divide it by the number of spaces. So for my common difference D, I could do 15 minus 25 divided by, it's really the positions, but it's the number of spaces in between, all right? So I would divide that by 2, and that would get me my common difference of -5. All right, I can just show that real quick. All right, so I'd get that -5 that way. I'll just make a little note. And then I'd write my rule, a sub n is equal to a sub 1 plus d times n minus 1. All right, so 25 plus -5 times n minus 1. And you can test it out. If I put in a 1, I get a 25. That's my first value. If I put in a 2, I get a 25 minus 5, which is going to give me a 20, and so on. But I need a sub 10, which would be 25 plus, it's plus a negative, so -5. Just kind of cut that part out. Times 10 minus 1. So 25 minus 5 times, really 9, but I'll put the 10 minus 1 in there. And you get a result of -20. All right, so you could do it either way. Literals, we're solving for W. So P is equal to 2L plus 2W. I'm essentially just saying, or it's saying, I want to get W by itself. So I'm going to subtract off the 2L. So P minus 2L is equal to 2W. And then, again, the ultimate goal here is to get the W by itself, so I'm going to divide out a 2. On the right-hand side, that cancels to just a W. On the left-hand side, there's really nothing else you can do. So it's just P minus 2L over 2. All right? So that would be choice 2. You could break up the fraction. I'll show that in a sec, because it looks like they're trying to mess with you on that. It's not really a necessary thing to do, but because there are choices that kind of have that look, I'll take you through it real quick. Do a little copy, duplication. Oh, I copied it. I wanted to duplicate it. I thought I hit the right thing. All right, so I'm just going to bring it in a little bit. So you could do the old, I don't know if you've heard of it as rabbit ears. If you have a sum or difference in the top of a fraction and you want to break that fraction up, you can take each part on the top and divide it by whatever's on the bottom. All right, so that would be P over 2 minus 2L over 2. The 2's would cancel here, and so you'd get P over 2 minus L is equal to W, which is pretty close to a choice, but not close enough. All right. Since we got the correct answer here, we didn't really have to bother with that other stuff, but I can see a universe where that might actually happen. For number 10, of all the pizzas sold in February, what percent were plain deep dish pizzas? So they're suggesting here that we're only concerned with the pizzas that are plain and, that's what the comma represents in this case, plain and deep dish. All right. I already did the total, so I'll just pop those in there real quick, which you would need because we have to take the intersection of the two. So that's the plain and deep dish. There are 200 of those. We're going to take that 200 and divide it by 1,000. All right, so you can put it in a calculator if you want, but that's going to end up being 20%. Well, I'll put it in the calculator for you. And my percentages there. 200. Right? Now that's the proportion, but they have their answers in percent form, so I multiply by 100 and you get your 20. Number 11, solve for x. So I'll rewrite. We have negative 2, 3x minus 5 is equal to 9 over 2x minus 2. All right, so there's a few different ways to handle it, but ultimately I want to try to get the x's together on one side of the equation and everything else on the other. So the best strategy to get started here would be to distribute this negative 2, because the alternative to that would be to divide both sides by negative 2, but that doesn't really do what we want it to do, because, I mean, it'll work, but then you're going to take a fraction and make it more of a fraction. So it'll be fine, and it's probably, if you kind of come down to it, probably an equivalent number of steps, but you're going to be working with fractions where maybe you can avoid that. All right, we'll see. Negative 6x plus 10 is equal to 9 over 2x minus 2. I'm going to subtract the 10 from both sides. You can go either way with this. And actually looking at it now, I think I would prefer to probably bring the 2 over. And that wipes it out here, and it makes it a 12 on this side, so plus 12. This way I can add the 6x and keep my x's positive. It's really just a preference thing, but you can, like I said, go either way with it. I do need to add 9.5 and 6 together, right? So that's going to be equal to, so that's 10.5, 10.5x. But if we want to keep it as a fraction, which you can go either way with that if you want. It's a good opportunity to go over the fraction stuff in the Desmos calculator. You see that little fraction icon on the left side under the 7 in blue? You tap on that, What that means is that there's a fractional equivalent available. So you have a decimal answer. It's saying, I can put this in fraction form for you. So you tap on that and it converts it over. So we're looking at, on the right-hand side, 21 over 2x. All right. So I guess I can get rid of the plus sign here. Oops, I don't want to get rid of too much. So then I'm going to divide out the 21 over 2, or I think it's probably a little bit more convenient, multiply both sides by the reciprocal, 2 over 21. So I'll be left with x on the right-hand side. I'm going to take my 2 over 21, just hit enter here, get to a new line, 2 over 21, and multiply that by 12. All right, again, fractional answers available, so I tap on it, and I get 8/7, which is choice 1. All right, properties, so algebraic properties involving exponents. Number 12, the expression x to the 2a plus b is equivalent to what? So if you have addition within an exponent, this is keep the base, add the exponents, but in reverse, right? So what I would do is break this up. And actually, let me write the rule. So if I have, I'll say x, that's not an x to the second times x to the third. And I guess this really isn't a rule, it's more of an example. That would be x to the 2 plus 3 power, also known as x to the 5th. So the rule is if you have x to the a times x to the b, you get x to the a plus b. All right. This problem here is telling us to do the reverse of that. So I have x to the 2a plus b. That's going to be equal to, if I'm taking this rule, but going, instead of from left to right, I'm going right to left. This would be the same as saying x to the 2a times x to the b. All right, which is not either of these choices. The issue that we kind of run into is, so this is a correct version of the answer to the problem, but it doesn't match one of the choices, right? So what they did was they kind of took it a step further, right? So I could write this one here as x to the a plus a, because a plus a is 2a, all right? And use that same rule a second time, making this x to the a times x to the a times x to the b. And what they did was they got a little wise with this, and they said, okay, well, let's regroup, making this kind of a tricky problem. We'll put these two together and use keep the base, add the exponents, x to the a times x to the a plus b. All right. Now that's probably the most confusing way that they could ask a question like that. Right? So if you're in a jam, what you could do is make up a couple numbers. Make up a number for A, make up a number for B, and just check your choices and see what's equivalent. I'm just going to wipe all this stuff out. So let's say, I'll actually put in their original, x raised to the 2, I'll use a plus b. And you see what happens there? We went over this previously, but it wants to make it an ordinary plus. So what I have to do is force it in here. And one way to do that is to open parentheses. It's equivalent, so I'll just do it that way. All right. And then what I can do, because I don't really need to see the graph, is I'll take a choice. I'll take that first choice, x raised to the 2a, plus x to the b. All right. And it's kind of the same idea as before. If you want to look at the graph, you can, but you could also play around with the values of a and b and see if there's ever a point where they actually match up. All right. Regardless of what my a and b values are, these two graphs never match up. All right. So that's not going to be the right answer. And again, you don't really need the sliders. It's kind of fun to look at. It's when I put it in using A's and B's, Desmos assumes that I want to make a slider, so it makes it automatically, right? And if I delete one of them, it won't let me do anything. It's like, no, you have to have it there. So I just kind of live with it. So I'll go to choice 3 here, x raised to the a times x raised to the a plus b. So same deal. Let's get some parentheses in there. All right. So this one we knew wasn't right. Now, again, just like what I was saying before, we look at the two graphs and see if they map to the same location. It looks like they do. All right. And then I would play around with my sliders. And no matter where I go, so I'll move this here. I'll do it like this. Turn that one off. Turn this one on. It's the same graph because they're equivalent to one another. So it's got to be choice 3. They're asking what kind of function we're dealing with. All right, is it exponential? Is it linear? All that good stuff. You could just graph it. All right, so a lot of plugging into calculators here. If you recognize that you're doubling every step of the way, times 2, times 2, times 2, and so on, that's great. That's geometric. If you think in terms of a geometric sequence, geometric corresponds with exponential. All right, but if I'm not sure, I can put in the graph and see what my picture looks like. All right, so looking at this, it looks like it's increasing, right? But it's definitely not linear or absolute, because those are straight line segments or just lines in general. The only other thing I would say is maybe it could be quadratic, but then I would need to see more of the graph, all right? So I could go back the other way. If I wanted to put, let's say I wanted to put -1 in there, like -1, I would divide this, because if we're going up the line here, we're dividing by 2. Going down the line, we're multiplying by 2. All right, so if I take that point 0.0625, divide it by 2, so another value here would be 0.0125. I could put that in my table. I'll just tuck it in at the end here. Doesn't matter where you put it. That adds another point, but it's still not turning around on itself, because a quadratic is a U-shaped or an N-shaped curve. So there has to be a noticeable turning point in order for it to actually be a quadratic. Because that's not the case here, we would say, all right, well, that's going to be exponential. But also, just going back to what I was saying, by definition, if you're multiplying by the same number every step of the way, that's consistent with a geometric sequence, also consistent with an exponential function. They go hand in hand, all right? So, sorry, I'm just testing my pen out again. Number 14, Stephanie is solving the equation. Her first step is shown below. Right, so it looks like that 8 went away. I'm sorry, that -8 went away. It appears she did this move, canceled on this side, and added 8 to a -12 to get to a -4. That's the addition property of equality. All right, whenever you do something to both sides of an equation, right, so multiply both sides of an equation by a number, or divide, or add, or subtract, those are properties of equality. So it was kind of a dead giveaway here once I realized we added an 8 to both sides, that it couldn't have been the others because they're not properties of equality. All right, they're asking for the sum of 8 radical 3, and really this is a 1 radical 3. All right, so 8 radical 3 plus 1 radical 3. All right, think of this, kind of treat the radical 3 like a variable and only add the coefficients. So we're looking at 9 radical 3, which is choice 4. If those radicands, the number under the radical, if those were different from one another, there's a couple of ways I can handle it. One would be to simplify the radicals and then add them. I'll give you a quick example of that. The other would be to leave it alone. Actually, there's a third way. The third way would be put it in your calculator and see which one gives you the same decimal. Right? That's the, like if you're in a pinch kind of thing. So if I add 8 radical 3 and add to it a radical 3, I get that decimal, and I was like, oh, I think it's 8 radical 6. Well, no, it's not. Then I was, okay, maybe it's 8, or what's the next one? 9 radical 6. Nope. I'll just skip to the right one here. 9 radical 3. We get the equivalent decimal. All right, but let's say you had something like, I'll actually, yeah. So let's say 8 radical 3. Oops. Plus radical 27. All right. These are two non-like radicands. All right, but what I can do is I could simplify this one. The 3 is a prime number, this 3 here. So I'm going to leave that one alone. But I can break this up into the product of radical 9 and radical 3. Radical 9 is 3. Radical 3 I can't do anything with because, again, it's prime, or the number under a radical is prime. But now I can add these two radicals together because their radicands are the same. Again, the number under the radical needs to be the same in order for you to add the coefficients. I would get 11 radical 3. Okay, moving on to number 16. We have dot plots for 20 students taking a math test. It tells the mode for this math test is 80 and the median is 85. The mode is the most common. Pen died again. I think that's up to like 3 times that the pen has died. That sounds right. There we go. So the mode is the most common. All right, and so that would eliminate Roman numeral 4 here because 80 being the mode is not the most common. All right, it looks like 85 is. And same deal with Roman numeral 2. 80 is actually among the least frequent. 85, again, is the most frequent. But we have a tie between choices 1 and 3. Now, the median is 85. That's the middle number. All right. So the halfway point in the data set should be an 85. There's 20 values so far. So the 10th and 11th value, or so far, 20 values overall. So the 10th and 11th values will make up the median, because the technique for that is to take that 20, divide it by 2, you'll get a 10, right? And then we take, because it's a whole number, we take the number 1 greater. So this would be the 10th and the 11th values. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th and 11th values are both 85. Whereas in this one, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th and 11th values are 80. The median is supposed to be 85. So that would be this number. I'm going to take a second here. So it's choice one. I'm going to take a second here and show you the brute force approach, which, again, like some of the other techniques I showed you, it's in case of emergency, right? So and this one really would be in case of emergency, because I would have to create a graph or do a calculation for each one of these, right? But what I could do is type, I'm just going to look at choice one, 65, 70, 75. We have 6 80s, so 1, 2, 3, 4, 5, 6, 3 85s, 5 90s, 3 95s, oops, and 1 100. All right, so I have my data in. Give it a quick double check. Now you could already see you probably don't want to have to do this 4 times. All right, so I can a couple of different options. If I want to go median, I could do that. But I could also use stats. You just have to tell it where to find the data. Data's in X1. So I would type in X1, and that gives me not just the median, but it gives me the 5-number summary. So I only bring this up because we're probably going to need this more frequently than anything else related to just the median. So it was worth, I guess, talking about. Number 7, they're asking what the domain of this function is. Basically just asking how far left and how far right, all right? So my leftmost point here is a -2, but that's an open circle, all right? So that means here we're saying that x has to be greater than -2 because it can't actually be a -2, all right? It's got to be greater, all right? But then it never stops increasing, so it goes on to infinity. So there's no cap. There's no point where you'd say, okay, well, it starts here, but it stops there. It starts here, and it never stops. So the notation, we say that the variable is x. That's what this means, such that, all right? So that vertical line means such that x is greater than -2, which is choice 1. It's just kind of a weird, well, currently kind of weird. Just, you get more and more used to it, but this is their first go around with this kind of stuff, so it probably feels a little uncomfortable. Let me just show you what it would have looked like if there were 2 endpoints. So let's say we had a solid point here and a point here. All right, both solid points. So this is an example. Here I would say it's still a variable x. All right, they indicated it there, such that x is greater than or equal to a -2. All right, so this is x is greater than or equal to -2, and this would be x is less than or equal to 3. So I'd write that as a compound inequality, saying that we're going from -2 to 3. All right, and I'll just do one more here. Let's say you have a closed circle here and an open circle up here. And again, it doesn't really matter what it looks like along the way. It goes a little too vertical there for my taste. All right, so here we would say x is greater than or equal to -2. And for this part, I would say x is less than a 3. So this example, I would say, again, x is my variable such that -2 is less than or equal to x. Right? And in a compound sense, so additionally, x is also less than 3. So -2 is less than or equal to x, which in turn is less than 3. All right. Number 18 is kind of an ugly looking question, but it's the point slope form of a linear equation. It just looks kind of funky. So one thing I could do is I could actually just add a 1 to both sides to make it a little nicer. But when they say which ordered pair is a solution, they're saying if I plug in these numbers to this equation, which one will check out, all right, where left side equals right side. That's, in my opinion, all calculator all the way, all right? So y minus 1 is equal to 2 times x plus 1/4. All right, so that's my graph. And really, I mean, unless you want to actually do the computation, just start typing. I mean, you could, there's one thing that you could do off the bat, because I noticed that we have a y value of 0 here. I could see what the x-intercept is. Now that's close, it's negative 0.75, not positive 0.75, so that's not great, but it was worth it. It was worth taking a stab at it. All right, so then I'll look at choice 2, and maybe the y-intercept, but there's no solution, no answer that has an x value of 0, so that wouldn't really work anyway. But I'll try the 1.25, comma 4. It falls on the line. What more can you ask for? That's what they're looking for. To play it safe, 2.5, negative 6.25, 6.5, I should say. Off the grid. Yeah, there it is. Not on the line, so no help there. And then 4, comma, negative 9.5. Same deal, not on the line, so we're good. Yeah, like I said, the alternative to this would be to actually solve by plugging in each ordered pair into this equation, x for x, y for y. So I'd have to replace this with a 1.25 and then replace that with a 4. So this would simplify out to 3 over here. And then we'd have, well, it would be 3 on this side also. So 3 equals 3, it checks out. But you'd have to do that for all 4 choices, or at least until you get to the right choice. Just be mindful of little things like sometimes they don't say which is a solution, they'll say which is not a solution. And 3 of them are right, but 1 of them's wrong. So just be careful about that kind of thing too. All right. Elena's fastest time for the 50-meter dash is 7 seconds. All right. So she wants to know how fast this would be in inches per minute, because you got to figure that's what would be on everybody's mind. How would this be if I were thinking in terms of like snail speed, right? Inches per minute. So it's basically saying that we're doing a conversion of meters. Yeah, meters per second. So this is really 50 meters in 7 seconds. And we want to get that to inches per minute. Now, I'll, just for the sake of not flipping back and forth, I'm going to just bring up on my laptop here the formula page, and I'll just kind of take a picture and dump it in here real quick, just so you can kind of see. This is, if you go right to the very end of the Regents booklet, you'll see all the conversions. They'll let you know this on the day of the exam, but they give you a bunch of formulas like compound interest and things like that. But if you don't know to look for it, then it could be lost on you, which would be pretty frustrating. All right, so this is something that they give. And in my opinion, they only give this information for the sole purpose of asking this very type of question. So take that for what it's worth. I need to go from meters per second to inches per minute, all right? So the easy first step would be to take care of the time component, because there's 60 seconds in 1 minute. So I'm going to multiply by a ratio that's equivalent to 1, all right, with the idea that I want to cancel out seconds and introduce minutes. So I would put 60 seconds up top and 1 minute down in the bottom. All right, these two things are equivalent to one another, so it's just like multiplying by 1. All right, so you're not changing the value of the fraction. But I get rid of the seconds units, just like I would if it were simplifying a fraction, where I cancel out and reduce my fraction down. All right, so now I'm down to 50 meters per 1 minute. All right, I need, instead of meters, I need to be in inches. So they give us that relationship here. 1 meter is equal to 39.37 inches. All right, so I'm going to multiply by another fraction where I cancel the meters. So I'll put meters on the bottom, 1 meter, and 39.37 inches up top. All right, so my meters cancel, and the only units that remain are inches and minutes, which is what we're looking for. All right. So if I wanted to go to the distance here, my next step in the calculator would be to multiply across the top. So 50 times 60 times 39.37. And then on the bottom, I would just have 7 times 1 times 1. So this would be 118,110 inches every 7 minutes. All right, and so then I would take my 118,110 and divide it by 7, and I would get this, which would be 16,872, depending on how they ask it around, 0.86, and that would be inches per minute. All right, that's all well and good, extra stuff that I just showed you that this question's not asking for, but it could. They cared more about this. So we start off with 50 up top and 7 on the bottom, so let's get rid of these two. The second thing that we did was seconds and minutes. Okay, both of these choices, 3 and 4, have that same thing, but it isn't until we get to choice 4 that we see that we have that proper ratio at the end. All right, so choice 4. Interquartile range. So this goes back to something I was talking about before. We'll put our data in. I'm just going to wipe out all this stuff. So create a table. 1990, 1991, all the way up to 1997. If it's consecutive, the Desmos will pick up on the pattern and save you a couple of seconds. All right, now they want the interquartile range. All right, so, oh, actually, apologies. We didn't have to put the years in because we only care about the temperatures. All right, if I were doing a correlation, I would need both columns. But here, I just want to find the interquartile range for this information. You think of the years as like labels, right? So you might say, oh, okay, we waste some time. That's not the end of the world. It's not like I have to delete it and do it again. All I'd have to do is go into stats and type in the previous example that we did related to this idea, it was X1, but the data I care about is in Y1, so I'll type Y1. That gets me my 5-number summary, which I'll make a note of here. So 77, 79.5, 85, 90.5, and 95. Your IQR is your Q3 value minus your Q1, which is 90.5 minus 79.5. And if you want to throw that in the calculator just to play it safe, we get an 11, and that's my interquartile range. Yeah, so a couple of unnecessary steps, but we made it through. All right. Number 21, the function f of x equals x squared is multiplied by k, where k is some negative number. Which of the following could represent the graph of g of x, right? So what this is a scale factor. When you do transformations, I could show you real quick. So let's say we have f of x equals x squared. Go home. So that's what my typical graph looks like. All right, that's the parent function y equals x squared. So now I can do it as y equals k times x squared. All right, because they're saying that we're taking it and multiplying it by k. So I'll just do that and throw a slider in for k. They're saying k is less than a -1. What would it look like? Well, if it were k equal to -1, it would be just a mirror image. But if it's less than a -1, it's going to get skinnier and skinnier. All right, so we're looking for one that's downward facing and also skinnier than your typical y equals x squared graph, and that's going to be choice 4. All right, solving a linear inequality. We have, I'll just write it off on the side here. All right, I want to group my x's together, so I'm going to add a 2.8 to both sides. Apologies. This, when you're in, actually I didn't need to erase it all. When you're kind of in a groove, sometimes you say or do things you don't even realize. There's only one x, so I want to subtract off the 6.4. All right, so that's going to get me a negative, so this will cancel, -4x greater than or equal to -9.2. I'm going to divide out the -4. So I'll have x, but because I divided by a negative, I have to flip the sign. So then we're looking at -9.2 divided by 4, which is -2.3. So I want my shading to be left of -2.3, but also including it, all right? So include the -2 is it negative? No, it's positive, sorry. So snowball effect, 2.3. So we want to make sure that 2.3 is included in the graph and that we're shading to the left of it. That's going to be choice 4. Number 23, number of fish in a pond is 8 more than the number of frogs. Total number of fish and frogs in a pond is at least 20. If x represents the number of frogs, which inequality can be used to represent this situation. All right, so let x equal number of frogs. Number of fish is 8 more than the number of frogs. So x plus 8 is equal to the number of fish. Put them together and it's going to be at least 20. All right, so x plus 8 at least is greater than or equal to 20. I can combine like terms here. I got a couple x's, so 2x plus 8 is going to be greater than or equal to 20. That's as far as they want us to go, so we can stop there. That's going to be choice 2. Number 24, it's asking which graph is always decreasing over the interval. So that's not anything too crazy. You're just looking for the one that as you go from -3 to 3 is always going downhill. All right, so we'd find -3 on each graph. -3 is here, +3 is here. All right, it's going uphill. Decreasing would be downhill. So -3 is here, 3 is here, same deal. -3, and it does say always. So at -3 here, oops, here, it's increasing followed by decreasing. It's going uphill, and then it's going downhill, so it can't be that. And even though for number 4, choice 4, I should say, even though there's a break in the graph, there's never a point where it's not going downhill. It's always going downhill, all right, regardless of where you are in that interval.